Good evening, I'm Gabriel Immanuel. Today we are going to discuss about aggregate. Our discuss topic are definition, gradation, fine modulus, classification, and physical properties. What is aggregate? Aggregate is a grain of natural or artificial mineral material that functions as a filler in a mortar or concrete mixture. Gradation is consisting of three: uniform gradient, aggregates consisting of a narrow limit of size fractions that have the same size will form a uniform gradation curve. The second one is continuous gradation. Aggregates consisting of all grain size, therefore it is best used in concrete mix. Gradation of gaps. Aggregates that missing one of the grain size, therefore the composition is poorly graded. Fine modulus. Fineness modulus is an index used to indicate the fineness or roughness of the aggregate grains. Fineness modulus is defined as the cumulative percentage of aggregate grains left or retained on a set of sieves and divided by 100. The arrangement of the sieve holes is 36 millimeters, 19 millimeters, 9.6 millimeters, 4.8 millimeters, 2.4 millimeters, 1.2 millimeters, 0.6 millimeters, 0.3 millimeters, and 0.15 millimeters. Classification. Geologically, aggregates divided into two: natural and artificial. Natural aggregates are aggregates that are spherical in shape and have a relatively slippery surface compared to the artificial aggregates because these aggregates are eroded by water. Artificial aggregates are aggregates made by utilizing advanced technology and human effort for their production. Based on size, aggregates divided into two: grain size 4.8 to 40 millimeters, or known as coarse aggregate. Coarse aggregate is also known as gravel because of natural disintegration of rock or in the form of crushed stone obtained from the stone crushing industry. Grain size 4.8 millimeters. Fine aggregate for concrete can be in the form of natural sand because of the natural integration of rocks, or in the form of artificial sand produced by stone crusher. By shape, aggregates can be divided into five. The shape and the texture of aggregate uh, affect the stability of the pavement layer formed by the aggregate. These are the shape. The first one is rounded aggregates found in rivers in general have been eroded by water, so they are generally round. The second one is oval elongated aggregate found in rivers or former river deposits. The third one is cube-shaped aggregates produced by a stone crusher which has a wider contact area, thus providing a greater interlocking. The fourth, flat flaky aggregate, the result of a stone crusher machine, or indeed it is the nature of the aggregate which when broken tends to be flat. And the last one is irregular shape aggregate. The surface texture of the aggregate consists of very rough, smooth, and smooth polish. Physical properties. The characteristic of aggregates that affect the quality of concrete consists of granular shape and surface state. Aggregate granules are usually round, aggregates originating from river or beaches, irregular, sharp angles with rough surfaces. Some are flat or oval. The shape of the granules affects the surface area of the aggregate, the amount of mixing water in the concrete, the stability or the durability of the concrete, the workability and the strength of the concrete. The first one, the aggregate strength. Aggregate strength is the ability of aggregate to withstand external loads. Aggregate strength capabilities include tensile, compressive, flexural, shear, and elasticity strengths. Aggregate density. Specific gravity is the ratio of the weight of an object to weight of pure water in the same volume at a certain temperature. Consistent properties of aggregates. The permanent property of aggregate is the ability of aggregate to withstand excessive changes in its volume due to changes in physical conditions. Third one, aggregate alkaline reaction. Alkaline aggregate reaction is a reaction between alkali Na2O, K2O contained in cement with active silica contained in the aggregate. The reaction of alkali hydroxide with activated silica in the aggregate will form alkali silica bubbles on the surface of the aggregate. The bubbles are water binding, which further expands the volume of the bubbles, causing cracks in the concrete. Thermal properties. Thermal properties include linear expansion coefficient, specific heat, and thermal conductivity. Linear development of aggregates as a consideration in concrete construction with varying temperature conditions. That's all that I can share with you today. Thank you for all your attention. Thank you.